Yeah, we're going to talk about houseplants because I have an obsession. It's a problem. These are some of my houseplants. I have about 3 or 4 dozen of them, actually. So that's just a sampling of the best-looking ones, right? How many of you have houseplants? And you love them dearly, right? See, this is the crowd I want to attract here. Okay, the tech people that also like houseplants for some reason. So these are my houseplants. I really enjoy when they look like this. And not like this, right? This is a very depressing looking plant. I forgot to water him, and that's totally on me. It's tough to take care of houseplants. Like all the people that raised their hands, you know, right? It's an effort. Even if you only have a couple of them, you get caught up in life, and you come home, and maybe you have something like this that just looks really depressing. So I figured, all right, is there a better way for me to be doing this, right? I'm a creative and technical person, right? So is there a solution that I could actually build for this, right? And you know, solutions do exist already, like ways to monitor your houseplants. Like I can hop on Amazon right now and probably have it at home by the time I get there. You know, some sort of way to monitor my houseplants. So of course there are better ways for me to be doing this, but I want to do it in an interesting way, right? I don't want to just buy something. So let's do it in a better way, right? The more interesting, maybe not. Oh man, we're just going to keep winging it. I will hold that.
I don't think it's the adapter. We can use it if we want.
Is it the adapter?
It's just
okay.
This.
Okay.
Do you need the?
No, it's okay. I am flexible. Cool. All right. Yeah, no problem. It'll come back, I promise. There we go. All right. Who needs slides? I'll mime it all out. Really? I think I was in the one session where this happened, and anyway, so the whole point is that I'm going to do this in the more interesting way, right? I want to build something. I'm an engineer. I have skills, weird skills, but I've got skills, right? And probably most of you are here because you are curious and creative in that way as well. So I am a developer advocate. I used to, prior to this in a past life, I used to work with Apache Kafka building streaming data pipelines with that technology. And so when I became a developer advocate, I promised myself that I would only build things that were practical, that were useful to me. And what that means is that there's always going to be overlap with my hobbies, all right? And so this is the perfect opportunity for me to use Apache Kafka to solve a problem that I have, right, monitoring my houseplants. And I'd also wanted an excuse to do a hardware project, right, buy a Raspberry Pi, and this was it. This was the perfect storm, right? So I wanted to build an event-driven system that would help me monitor my houseplants. I'm not going to dive too deeply into this yet. We're going to cover each of these stages when we actually get into the talk. But this is what I had in mind, right? I wanted to build it on Apache Kafka and be able to receive some sort of alert on my phone, right? Because I'm a lazy person. I always have my phone with me, so that made sense. All right, so Kafka. How many of you have used Kafka before? Not nearly enough. Perfect. All right, so for those of you who did not raise your hand, don't worry. You'll get a quick primer on this. So what is Kafka? Well, it's a distributed event streaming platform. 3 simple words, right? What could go wrong? There's a lot in there that we should unpack, and let's do it together. Okay, but quickly though, because I only have like 20 minutes. So it's a streaming platform, okay? Not like Netflix, right? We're talking about streaming in the data sense, right? So over the last 10 years or so, we've been undergoing a paradigm shift in how we work with our data, how we process it, how we store it, how we move it, right? And so we're moving away from batch-focused systems that are typically slower, and we're moving towards streaming, toward real-time processing. So instead of waiting minutes, hours, days, weeks, months, I don't know, to batch data together and then process over it, we're instead pushing back, and we are building systems that react to smaller pieces of data as close to when those pieces of information are created as possible, right? Because data is more valuable the closer to when it's created, right? I think we can all agree on that. So there's a lot of technologies that can help you do stream processing. Kafka is just one of them, but there's a lot of benefits to it, okay? You're going to be increasing the accuracy of your data and results in most cases. You are obviously building a more reactive system, right? Because you're reacting to smaller pieces of data. And in the case of Kafka especially, you can actually build a more resilient system, and it's a very loosely coupled system as well. So there's a lot of gains that you can get from that. So Kafka is a streaming platform. More than that, though, it can serve as a messaging system, as just pub/sub, if that's what you need it for. You can use it as a persistent storage layer. Is Kafka a database? I'll let you think about that. And also, as we'll see, there's a lot of processing components in there so that we can actually unlock stream processing. All right, so it's a streaming system, but it's also an event system. What are events? Well, this is probably the most important thing. For those of you who did not raise your hand saying you knew about Kafka, to use Kafka successfully, you need to start thinking in events. They are critical to this technology, all right? And this isn't me asking you to rewire your brain, I promise. We already know how to think in events. As humans, as programmers, as users, this is a very natural thing for us to do. Every time you submit a form online, every time you use application log files to debug something, every time you get a notification on your phone, those are all events, okay? So those are examples of events, but what is an event? Well, it's something, it describes something that has happened. That's it. It's that simple, okay? So what do we need? We need a timestamp. We need to know when that thing happened. We need to know who or what was involved, and then any other supporting details, right? So going back to this system with these plants, right? I want to build a system to monitor my house plants based on their moisture levels, right? And so an example event would be, say, yesterday at 12:30, I had a moisture reading of this plant, and it was at 19% moisture level. Okay, so we have the timestamp, yesterday at 12:30. We have the subject of this event, which is this particular plant, and that supporting detail was that it had a moisture level reading of 19%. Okay, that is an event. It has happened. Another thing about events that you really need to internalize is that they're immutable. I'm so sorry if immutability is not something that you like. It just is what it is. And it's not me being a complicated person and telling you just to be difficult. Events describe things that have happened in the past. It occurred already, okay? We don't have time machines. I can't change that. Now, that's unfortunate because if that plant has a moisture reading of 19%, it's almost dead. It's a sad plant. So I would like it to not be that, but I'm not going to erase that event. I'm never going to delete that event because that thing happened in the past. What I could do is I could water the plant now, and sometime in the near future, we're going to do another moisture reading, and it's going to be, say, 70%, right? And so I'm not going to toss out that old event. I'm simply going to take the new one and append it to a timeline of events that describe the moisture status of this plant over time. All right? So when you work with events in Kafka, you're always building up sort of a timeline that describes the entities in your system, okay? So based on what you learned about Kafka being a streaming system that helps you move your data quickly and build a reactive system on top of that for stream processing, and the fact that you're communicating immutable facts, this is really powerful. For those of you who have embraced immutability, you know what sort of benefits you can get from that, right? Namely, that anyone can read that data, right? And you know that you're maintaining the integrity of that data, despite how many people might be reading it. Okay, so that's really valuable in a fast-paced system. Okay, so to understand, though, how Kafka is doing this, how it can move your data and stores your data, we need to look a little bit more into the architecture. So it is a distributed platform, for better or for worse. I know sometimes they get tough, but here we are. So how do we store data in Kafka? Well, we use something called a topic, and a topic is just a data set, right? Just a data set, okay? Consisting of these events. So it's effectively a timeline. You get data into Kafka using a client called a producer, and you write data as key value pairs. You can have as many of these producers as you want, within reason, but it's a pretty high number. From there, you get data back out using a consumer, all right? And a couple cool things about consumers. The first thing is that if I have an endless timeline of events that I'm constantly writing to, and I'm a consumer, well, I might want to take a break at some point. Maybe the node has rolled, I don't know, but that application might go down. And so it's beneficial for a consumer to keep track of where it's left off, right? So it does that using something called an offset. It's just a bookmark of where the last event that it read in that timeline, in that topic. Consumers can work together as part of a group, a consumer group, and this means that they are able to potentially parallelize the processing of the events from the underlying topic or topics. On the other hand, consumers can actually work completely independently, and this is a really, really powerful thing, that consumers are able to read the exact same data and get the same events from a topic without impacting the other consumers, all right? It's easy when you're learning Kafka to compare it to a similar technology, and messaging queues always come up. So a Kafka topic is not a messaging queue, it is a log. All right, just like an application log file that you may use for debugging, as you read line by line through that file, nothing happens to the data in it, right? It's durably stored in that data, in that file, until the log rolls, which is similar in Kafka as well. You could define how long that data is stored. And until that log file rolls, anyone can come along and use that to build up that same state of that application in their minds and use it for whatever purposes they need it for. All right, so a Kafka topic is a log, very similar. The producers and consumers completely decoupled from one another. They don't care who, the producers don't care who's reading the data, the consumers don't care who put it there. And that is wonderful because they can keep running even when the other one might go down. These topics are further broken down into components called partitions, that you see an example of that on the right here. And these partitions are actually themselves the append-only logs where the immutable events are stored, okay? And I'm not gonna get into this now, but by breaking the topic up into smaller components, we can actually store this data across the cluster, across the distributed system, and then we can also copy it and provide other copies for better durability and high availability of that data. Okay, back to the cool thing. All right, so Kafka. So now that we have an idea of what this is, we can actually build this system, right? And step one of building my plant monitoring pipeline is to have a cluster. Okay, that's it. We just got to get one of those. So I work for Houseplant, and so we provide fully managed cloud-based Kafka. And so when I went into this project where I was going to be, heads down, building a physical hardware system, it was my first hardware project. Again, I'm really lazy, so I didn't want to maintain any infrastructure, so I used a cloud-based cluster. On top of this, there are some cool benefits that I get from using this cloud-based cluster. Kafka Connect, a way to move data in and out of Kafka and connect it to other sources and syncs. ksqlDB is actually provided in browser with Confluent Cloud, so you don't have to run any applications externally. And then also schema management is built in as well. So if you want to build something similar, just have a Kafka cluster running. They could be running on containers on your desktop or elsewhere. It doesn't really matter. You can actually run them on Raspberry Pi if you felt like it. So just have a cluster. Okay, step one complete. Now let's build the system. Again, we're going to do a little bit of hand waving here, but if you want to build something similar, how many of you do hardware projects? Okay, I'm surprised it's not more. It's the Python conference. Okay, so this is the equipment that I bought for this. The Raspberry Pi, completely overkill for this project. I didn't need that one, but there's still a shortage, so you take what you can get. Another thing to call out is that I was using these capacitive moisture sensors, and they're I2C components. What does that mean? Well, when you actually wire up these I2C components together, they're all going to communicate over the same input wires into the Raspberry Pi. And so in order to actually fetch data from the individual sensors, you use a unique address to access them, all right? And so that's great, but that means that every sensor needs to have a unique address, which they sometimes don't. And so in the case of these ones, which were only like $1 each, maybe less than that, I could only set the address to one of 4 values, which is very unfortunate because I have like 30 plants. So just know that going into this, I was only able to hook up 4 plants at a time. Those of you who do hardware projects, you'll probably say, yes, there are software ways around that. There are hardware ways around that. Doesn't matter, outside of the scope of this topic. All right, so let's write some data into Kafka, but let's not get ahead of ourselves. So my biggest piece of advice to anyone starting any project, because any project has some sort of data, is just to take a step back and understand what data you're working with, okay? This really helps me, even though I'm the only stakeholder of my projects, right? But it allows me to just see what the overall goals, what the long-term goals are for this project, and understand what fields are actually necessary right now, and what might be necessary later on, okay? So I have some goals to work towards, and I know how to reason about it. So the first data set that I wanted to work with are the readings that I'm actually capturing from the Raspberry Pi. Really simple data set. So it's just the percentage moisture that I'm capturing from that sensor. I get temperature for free, so I figured I'd add that in. And then I also need to identify the plant in question, right? So I took those fields, I created an Avro schema that I can store in the schema registry alongside my Kafka cluster. And great. Now all I have to do is write the data according to the schema. There are 2 ways to get data into Kafka, 2 main ways. You have the Producer API and Kafka Connect. The Producer API, this is your low-level sort of vanilla way of getting data into Kafka. It's really great, it's flexible, it's available in all of your favorite languages, and here's my lame joke, and some of your least favorite languages. So you'll want to use the Producer API when you either own the application that's generating the data, or you have access to it, right? So if I'm building a website and there's some very specific thing, like a click of some button that I would like to log that. I want to know when that happens and have that written to Kafka. I'll just add a producer. It's like 2 or 3 lines, add that in and write that data into Kafka as it happens. The other option is Kafka Connect. And Connect is it's a framework that runs alongside Kafka that runs connectors that are able to connect with sources in this case, and also sinks, as we'll see later on, to bring that data, translate it into events, and write it to Kafka. So for reference data sets that might exist in a database, or maybe you have legacy systems where you're constantly writing to Postgres and you want to be able to pull that into Kafka for processing, you're going to use Connect. So what did I end up using in my case? Well, I own the Raspberry Pi. I am the only author of this script, so we're going to use the Producer API. I'm specifically using the Confluent Kafka Python library, and I'm using the Serializing Producer because I have a schema that I need to serialize this data accordingly. You will recall that I need to reference each sensor by its unique address. And so what I did is I defined a hard-coded mapping. That should be a red flag. Hard-coded mapping of the sensor address to the plant ID, the plant that moisture sensor is actually in. Then within this script, every 30 seconds, I am looping over that mapping. I am capturing the moisture value from that sensor, computing the moisture percentage, creating a reading object, serializing it, and producing it into Kafka, right? So we're just doing this every 30 seconds. I've changed that value a couple times since I've played around with this, but 30 seconds seems to be a good interval for me to be collecting this data. And I will link to this code later if you are curious. Okay. So I'm producing these readings into Kafka. Great. Is that enough for me to be alerting on? Probably not. Every houseplant is different. If you don't believe me, get a couple plants, all right? They all have different needs, different time periods when they need to actually be watered. So a 20% moisture level for one plant might be completely different from a 20% moisture level on another one, right? One of them might need to be watered now, and the other one might have a couple weeks left, right, before it needs to be watered. And so I need a little more data to actually act on these readings. And so let's toss in some metadata, some hand-wavy metadata. So this is where I did a lot of research on my plants to understand what percentage moisture levels they are actually comfortable within. And I created a schema accordingly. So we have the plant ID, so I can join it back onto those readings. We have a bunch of names, like the scientific name, what name I actually gave it, because all my plants have names. Then the low and high moisture threshold as well. How do I get this data into Kafka? Well, I don't have a database where this data lives, right? So I can't really use Kafka Connect to pull for those updates and create it and push it into Kafka, right? I'm not going to create a database to store this data because, again, I'm a lazy person, and there's really only 4 plants at a time that I need to monitor and write this data for. So I'm going to use the Producer API. I'm going to use the Confluent Kafka Serializing Producer again. And even though this is slow-changing data, right, and it should probably live in some sort of database somewhere, I'm going to write it directly to Kafka just out of convenience. But I don't want to have to log into my computer and write every time I want to write new metadata, right? So at the end of this, I want to receive alerts on my phone using Telegram. So I figured, let's use Telegram to also write this data, okay? And how many of you have used Telegram before? Thank goodness. Okay, so happy. It's the coolest thing. It's my favorite messaging app, mostly because it has a really rich API around it. And so you can make a bot. You're given an API key, and you can use that API key to validate your bot, write a Python script using their wrapper library, and define how people can have conversations with that bot and what your bot's going to do in response. And so what this means is that I can use it, build a Telegram application that's basically an admin console for me, that I can write this metadata to Kafka through. And so I define a conversation handler, how I'm actually going to interact with this bot. It's going to request at each stage different information from me. So I define this sort of like finite state machine of what happens in each stage. And then within the individual handler, I capture the user input, store it temporarily in state, ask the next question and forward it to the next state of the conversation. So I keep doing this, and at the end, once I've fetched all the information, I can then just insert a producer here and write it from my phone. So I don't have to actually log into my computer now to write any of this data, which is wonderful. And so in the end, when I have this running, this is the sort of flow that I go through. It confirms the information and then produces it to Kafka for me. So what this means is that I can add new metadata. I can update metadata whenever I need to. But it's really that adding of metadata that's a big deal now, because you'll remember I have that hard-coded mapping of plants to sensors. And so that's not good, right? If I'm adding new metadata, I need a way to also update that mapping. Okay? And so I'm going to create a way to update that mapping from my phone as well and use this schema. So this is just a sensor ID to plant ID. Very, very simple schema. And I'm going to add another conversation handler that allows me to select the sensor ID that I want to update, right? So the limited addresses that I have available, say which plant ID I want to map it to, and then that is in Kafka as well. Now, all I have to do is add a consumer now on my Raspberry Pi script to actually make use of that mapping, all right? So how do you get data out of Kafka? Consumer API or Kafka Connect. In this case, we're going to use a regular consumer. And so before that, right when that script starts up, before it starts pulling for data, it's first going to read through that topic of mappings. It's going to build up a full mapping of the 4 sensor IDs, right? It needs a full mapping in order to start running, right? And then after that, it will start pulling for the data and then check for more updates on that mapping topic. An important thing here is that I'm not going to use any of those consumer bookmarks that I talked about. I want this consumer to start from the beginning of the topic every time, just so that we have that full mapping of 4 sensor IDs that we need to actually run. And to do this, I'm going to use a non-committing consumer, and these are the configuration values that I would use to set that up. And then also the topic that this data is being stored in is going to be a compact topic. What that means is that every so often, this topic is going to go through and look at old values per key and get rid of those. So it's constantly going to be optimizing the topic itself, and then our consumer is going to sort of minimize the amount of data it needs to actually go through to build up that full mapping. So now, within 30 seconds or so of me inputting new data or a new mapping, the Raspberry Pi script is going to see that, and I can switch the sensor, and I can add a new plant to it. Great. Okay, all of that just to get the data into Kafka, and now we're ready. Now we can do something fun, all right? So now we actually need to do the stream processing and act on these readings. So how do we process data with Kafka? Well, there are options. I'm not going to get too far into this now, but here's a pretty quick summary. We have the consumer and producer API. You are free to build up an application of just a vanilla consumer, read the data from Kafka, do your processing, and write it back to Kafka. That's fine. It's really good for stateless processing, because once you add state into the mix, it gets complicated. Kafka Streams is a purpose-built Java and Scala library for stream processing. It is adept at handling state. And it's able to, you can run multiple instances of the same application, and it will fail over any sort of input partitions that you have one instance processing. If that instance goes down, it will fail those partitions over to the other ones and take the state with it, so you don't have to worry about that. If you don't like Java, which is completely reasonable, I almost don't, we have ksqlDB, which is a SQL wrapper on top of Kafka Streams, okay? And this is what we're gonna use today. So ksqlDB, how do we actually use this for stream processing? Well, the first thing you have to do is get the data into Kafka. Well, it's there, but you have to get it into the ksqlDB application now. Define your inputs. And there are 2 sort of first-class citizens in ksqlDB. There are tables and there are streams. Streams represent ongoing series of events, and tables represent only the most recent value per key. It's kind of like a compact topic. So looking at this metadata first, we want to bring this in. This is going to be a table, right? Because anytime that I'm updating the metadata, I want the most recent value to be reflected in my processing. I don't want to look at the old metadata that's assigned to that plant. I want the new stuff. And so I'm going to use a create table statement to set this up. I'm giving it a name, houseplant metadata. I'm pointing to the topic where that data exists, and I'm specifying the value format, which is Avro, because we wrote Avro schemas. The cool thing here, and the reason that I spent all that time writing a schema, is that ksqlDB as a consumer looks at that topic, knows it has a schema, goes to the schema registry, looks at that schema, and uses that schema to parse the fields and types for this topic. And so I don't have to type out any of them. The only thing I have to do is define the string ID, just because it needs to know which key we're using, because it needs the most recent value per key. Okay, so I'm going to take that SQL, I'm going to run it in the Confluent Cloud Console, and then that data is going to be brought into this application. For the readings, every message is relevant in this stream, so it should be a stream. Very similar syntax of create stream from create table. You point to the topic, specify the value format, and you can run this, and this is available as input. All right, the data is in the application. Now let's do something. First, let's enrich the data sets with one another, right? The readings aren't good enough on their own. We need the metadata. And so I'm going to do just a regular join. And I want this to be persisted to another stream, so we're using a create stream statement. And I'm going to execute this join, just an inner join, selecting the fields that I actually want to be output here. But I want this data to be persisted somewhere. And if I only ran this query, this select statement, it's going to give me everything that currently exists in that topic. But I want it to be persisted. I want this to be a long-running query. And so I'm going to use something called emitChanges at the end. So what that means is that every time a new event flows in, we're going to execute this query, execute the join, and append that to this stream that we're creating. All right? So this is the intermediate stage where we're just joining the data and making this full stream of data available for the next step. And so this was called a push query, right? And this is contrasted with a pull query where it's just pulling as output what's currently in that topic, right? All right, so now let's act on it. What is the goal here? Whenever a plant has enough low moisture readings, I want an alert on my phone, right? But I'm taking these readings every 30 seconds. That's a really, really close interval for me to be receiving alerts on my phone, right? Every time there's a low reading, I don't want to get an alert every 30 seconds. That's ridiculous. So 6 hours, that seems like a good amount of time for me to receive an alert and act, right? Go back and water my plants. Obviously, I can't get back to California in that amount of time, but it gives me enough time to tell the person who's taking care of my plants to, okay, make sure you water this one, right? So again, I'm taking these readings every 30 seconds, a 6-hour period, that's what I want to send alerts within. And so it's probably good enough if within a 6-hour period, if I had 1 hour's worth of low readings, right? That plant probably needs to be watered, right? And these moisture sensors, they're not perfect. I get false high readings, false low readings, but the general trend is that they go down over time. So 1 hour's worth in 6 hours, that seems like a good enough thing. And so what that means, doing a little math, is that I need at least 120 low readings within a 6-hour period in order to trigger an alert. Okay, so this is the query that does that. This is the bulk of it. All right, few key details here. First of all, I want to receive an alert every 6 hours. So let's window. We're going to window over a 6-hour period, and it's going to be a non-overlapping tumbling window here. When an event flows in, the first thing we're going to do is we're going to figure out which bucket, which window it goes into. Within that window, and per plant, right, because we're grouping by plant ID, whenever a moisture reading is lower than that low moisture threshold, we're going to count, right? And only when that counter is above 120 are we going to output something. You might be asking, well, if you're still getting readings every 30 seconds, wouldn't I just get an alert after we hit 120, 121, 122, 123? Great question. No. So at the end, I have emitFinal. As opposed to emitChanges, where every event could generate an output, emitFinal says wait until the window has fully closed, and then assess and generate a result if you need to. And so what this means is that only after we've gotten to 120, after the window has closed, if that state says we have over 120 readings, we will generate an output result according to this select statement. Okay, cool. I know, I'm going to be over time. Ready? Okay, so that is cool. Now all I have to do is get the data out of Kafka. Now I have a message that says this plant needs to be watered. And now I need to get it out so I can actually use it. And I want it on my phone. That's all I want. It's a pretty easy ask. And so we already saw how to use Telegram as a producer. So let's now use it as another producer from the Kafka side of things, right? I want to move that data out into my phone. You'll recall that I defined a bot. I received an API key. With that API key, I can access the individual conversations that I'm having with this bot, and I can identify my personal conversation with a conversation ID. the Telegram API is super cool, right? So I can build up an endpoint using that API key and that conversation ID, and I can send data directly to that conversation. Okay? So building up that endpoint, why is that useful? Well, we have something called the HTTP sync connector, and so what all this needs is an endpoint to send data to. You point to a Kafka topic, and once you run it, every time a new event is generated on that topic, it's going to send the data to that endpoint. Okay? So all I had to do was point to those two things. And this is run completely in Confluent Cloud. I don't have to run it externally. It's just long running for me. So I use this to extract the relevant data from that last topic that we just built up. And so this is the alert that I receive on my phone. I added their names to make it a little more personal, so I feel bad. Okay. So I'm pretty happy when I get that. I mean, I'm sad because the plant's dry, but I'm pretty happy. So the plants that I have hooked up to this, I completely rely on this system to tell me whether or not they need to be watered. Like, I don't even look at them until I get a text, which maybe that makes me a bad plant parent, but whatever. Okay, so I'm pretty proud of this. This was my first hardware project. It was a cool project for me to play around with hardware, build something interesting with Kafka, and solve a problem that I had. Why should you care? Why? Well, I tricked you, because you learned a lot. So every streaming data pipeline is going to have some combination of these components. You need to know how to get the data into Kafka, right? And I showed you how to use the Producer API, how we could use Kafka Connect as well. You're going to do some sort of stream processing, and I gave you some of those tools, and specifically went into ksqlDB on that. And then you're going to use maybe a consumer or the Kafka Connect to get data out of Kafka later, okay? All of those components, you're going to use some of them to actually build up your streaming data pipeline, all right? And now you have those tools, so get on out there, build something cool, all right? I have some resources up here as well as the source code if you're curious to see how it was set up. And please go check them out and find me later for questions. Thank you so much.
Thanks so much, Danica.
Yeah.
I think before you all run off to lunch, the lunch is going to be served at 1:15, so we have some time for a little more questions.
Haha, you're stuck here.
Or you can ask Danica in the break as you want. But if you want to go now, that's also fine because the official time slot is over. So the first question is, it's more of a hardware-related question, but how could you make your setup work in a garden?
Oh, man. Well, Raspberry Pis aren't waterproof. You guys, you're so funny. Yeah, I did look into that. Unfortunately, I care about indoor plants more. The cool connection that I do have is that my boyfriend's sister runs a farm. And so that is actually a project that I do want to get into. She has agreed to let me put a bunch of hardware components everywhere and see what we can get out of that. But yeah, honestly, I wanted to set it up in my own garden at home, and I kind of gave up after build and a housing for everything, right? Because you have to make sure everything's waterproof. That said, there are some other sensors I've seen that are more expensive, they're more robust, that can actually be outside. There's also some like wireless sensors as well that work better outside. So it's flexible, and you could totally do this. I mean, as long as you pick your component, bring your own component, right? And then send it off to Kafka, and then the rest of it's the same, effectively, hand waving, right?
Great. And maybe the most important question, how are your plants doing with all the extra monitoring? Are they doing better than before?
I'm a helicopter parent now. Yeah, they feel like they can't escape. They don't get to live their lives. Those ones are doing really, really well. Like I said, like I completely rely on the system for the plants that are hooked up to it. I don't touch them until they actually need to be watered, until it tells me to. They are probably doing better than the rest of the plants, honestly. So it works, and that was like the coolest thing to actually see that it does work. When I first started running it, it took every ounce of my being not to water those plants before I was told to water them, right? It's like, oh, but you look, and then no, it's like the science says you're not ready to be watered. Okay, I need to wait, so.
All right, then thanks for sharing this awesome project with us. And
yeah.
Yes, you're ready for lunch. If you have lunch boxes reserved, you can pick them up at the registration counter. If you have a ticket for the Osteria, then you can go there as well. And all the others, you can go to the lunchroom, which is in the main hotel room. All right.
Great. Thank you so much, everybody.